So today we're looking at combinations. Combinations and permutations are really, really similar. The formulas are pretty similar, but basically the difference between them is permutation, the order matters, and combination, the order doesn't matter. All right, so we're taking our things from a group of n where order matters. Doesn't matter. So the way I remember these two and the difference between them is POM and COD. POM, permutation order matters. COD, combinations order doesn't. So that's just my own way of trying to figure them out. So the formula for a combination is very, very similar. It's still n factorial over n minus r factorial. But this time, because we do care about what order, we have to actually take out all of the ones that provide that permutation. So are you going to get a bigger set or a smaller set for combinations? Smaller, right? Because we don't care about the order in which we've taken them. So where we'd have 10 for permutations, we'd take out all of double ups, so who sits next to whose, and we'd reduce it down. Okay, so that's why the divisor has changed, not the numerator. So let's have a look. If we were looking at taking 3 class reps out of class, so 10 students put their hands up and say, I want to be the class rep. I've got to take 3 of them. Doesn't actually matter who is who. They're all going to be class reps. One's not going to be the super class rep, and one the not so super class rep, and one the other class rep. So they don't get special names. They just have the 3 of them. So what do? We've got 10 choose 3 is 10 factorial over 7 factorial, 3 factorial. All right, it is a button on your calculator, just the same. So still in that same options probability place, and you do put it in as 10C3, and it will give you the answer. So this is equal to 10 times 8 times 9, usually. And then the 7 onwards is gone, divided by 3 times 2, 15 times 8, 40, 120. All right, so it's usually pretty easy to work out anyway. Sometimes you'll find that this particular one has a different notation. So sometimes you'll find that NCEA is written like this. Specifically, this is written like this in what's called the binomial theorem. It means exactly the same thing, but some books actually use them interchanged as well. So there's often a case where this particular matrix looking thing is actually standing for NCEA. So that's just something to be aware of. Okay, so let's have a look at what happens when one of the class reps has to be Sammy. What happens to the problem now? Right, so one class rep has gone and one student has gone. Sammy's already in the pool of play. So therefore we're looking at NC2 this time, and that is equal to 36. So if we were looking that this is an arrangement, we'd have our box here, which is that first person had only one choice and then 2 choices for the others. All right? What if we can't have Dhruvi, HII, and Alicia. So we're not allowed both of them. Now what happens? No. So new situation. And this time when we select these three, we can't have Dhruvi and Alicia on it. 8 choose 3 options. We can't have both Dhruvi and Alicia.
9 people.
Tui, sorry?
9 people with 3.
Okay, who have you missed out? How many choices have you got for that first box? 10. And then you have 9, and then you have 8. But both people can't be there. So let's start with that as our assumption, all right? That we do actually have a group of 10C3, all right? We need to remove from that the possibility that we have both of them. And we looked at that yesterday, right? Having both of them means dealing with them as, yesterday, dealing with both of them as one thing. So we are saying, if we've got both of them, let's take that lot out. So that's like not having the both of them, correct? So we want to have 8C1. That's the amount of times that Dhruvi and Alicia will pair up. So think of it as Dhruvi and Alicia and one other person. So how many one other persons were there? 1 out of 8. Got it? So therefore we've got 120 minus 8 equals 112 ways. Okay, so you need to think about the problem really carefully. If you've got more than one choice, to make, so we could have this would definitely be me. Select at least 3 chocolates from 8 chocolates. Right? Definitely me. Select as many as I can. Not just 3. So we've got selecting 3, but we've also got how many ways I can select 4, plus we've got how many ways I can select 5, 6, 7, and 8. How many ways are there for me to choose 8?
1.
Good, just checking. All right, so that would be, I know what 8C3 is. This really cool thing called the binomial theorem that can actually work all of these out for you without a calculator. And quite often in the exam they used to have it in the formula sheet, may still, and that was an easy way of doing it. So it looks like this. I don't know if you've seen it before. Do you know what I'm doing? Making a pyramid by adding a 1 on the end and then adding, I'm really good at adding, I can do adding. No. This pyramid. It's called,
I don't have to say the name.
what is it called?
Pyramid.
36, 70, 36. 28, 8, and 1. All right. So this is 0, 1, 2, 3, 4, 5, 6, 7, and 8. So I want 0, 1, 2, 3, 36 plus 4, 70 plus. Of course, it would be a lot easier to have done it on your calculator, but I don't have my calculator in my hand, so I've just looked them up. And then adding them up, you will get 142, 150, 179. Is that right?
Wait, how did you choose those numbers?
Yeah. So it goes 0, 1, 2, 3, 4, 5, 6, 7, 8. Hannah.
How did you get 36?
Hopefully I added correctly. Not.
8 centimeters.
Okay, so we'll have 56 and 56, which makes an extra 40, so 219. Happy now?
Yeah.
Okay, good. All right, so you can see anyway, what I'm trying to say is you find each one and you add them all up. So you've got to remember that an at least or more than one choice means you're adding things up. If you've got two choices, then something else happens. So, for instance, if I've got to select 3 from something and then 2 from something else. So like I've got to have 3 boys from 6 and 2 girls from 5, 4, and that's just because of proportions. All right, nothing sexist about it. Just saying proportionally we want to see. I've got 6 boys, got 4 girls, got to choose 3 from the boys, 2 from the girls for representation. So what am I going to do? I'm going to go 6, choose the 3 boys, and I'm going to multiply that by every single case for the girls. So therefore it's going to be 4C2 for the girls. 6C3 is 20 times, all right, so 6C3 is 0, 1, 2, 3, and 4C2, 0, 1, 2 is 6. So therefore there's 120 different ways that I could work that out without my calculator. There is 120 ways I can choose 3 boys from 6 and 2 girls from 4. Because I times every way I can choose the boys by every way I can choose the girls. All right?
So they're technically a group of